Welcome to the Nokia Optical Networking Learning Essentials video series from the Nokia Optical Network Certification Program, an end-to-end learning program supporting Nokia 1830 PSS, VWM, and NFMT-based networks. Today, I'm going to show you how to properly check and configure the optical protection switch, or OPS device, in an existing 1830 VWM network. This video has been created based on the Nokia Optical Transport for Mobile Services course, which plays a key role in the Nokia 5G learning curriculum. Optical technologies and architectures based on the Nokia 1830 Versatile WDM Module, or VWM, are proposed for Fronthaul to meet 5G requirements and the Time-Sensitive Packet Switch, or TPS. 1830 VWM Fronthaul links can be effectively protected by using the Optical Protection Switch, or OPS device. Several parameters can be configured, and in this video, we'll explain how to properly check and configure it so that the traffic flows over the same side of the OPS ring, no blocking conditions are present, and the switching counters are set consistently on the two endpoints of the ring. Several components belong to the VWM solution. The purpose of this video is to focus on the OPS device on the right. As you can see, the OPS is in the active component. We will now focus on the configuration, which is based on several typical VWM components such as TLUs and filters, but also includes an OPS-protected DWDM ring. The purpose of the OPS device is to protect the line span, so that all CPRI channels transported between the cell site and the hub site, where we typically have the BBU, are protected against fiber cuts. The role of other components does not change. Let us now focus on the OPS device and analyze the block diagram depicted here. On one side, we have the SIG port. Here, the aggregated channels typically arriving from a filter are split onto ports A and B on the right. By default, A is considered to be the working port, while B is considered to be the protection port. The signal is then split onto these two ports. See the orange block. That means that both directions, both spans of the protected ring, are always used in the transmission direction. The selection is done at the receiving side. See the blue block, where the device can choose one of those two flows depending on alarms and depending on the software configuration. On this side, two connected OPS devices are represented. As you can see, the dotted lines have been drawn in the blue blocks only. That is the receiving side of both OPS devices. To be precise, the block diagrams shown so far are related to the optical switch module, or OSM, and the OPS device can host up to 4 such modules. Therefore, in case of multiple rings to be managed by the same CRAN hub, where the BBU is typically located, one single OPS card could be used to manage up to 4 different rings connected to 4 different remote sites. Each remote site needs to be equipped with one OPS device, and each of these OPS devices should be equipped with only one OSM. This lab aims to check the status of the two OPS devices and to resolve any blocking condition to recover the full functionality of the protection system. As depicted in the network diagram, there is a protected ring between the central office hub and the intermediate aggregation site, which is managed by two OPS devices. Let us connect and verify the status of those packs. The alarm list is a good starting point for troubleshooting. Show ALM summary. 2 OSM-related alarms are there, upstream, downstream, not synchronized. Before proceeding further, a note: such issues related to the OSMs do not affect traffic directly. In other words, issues related to the OPS configuration may cause synchronization issues or might prevent the devices to switch in case of a fiber cut. But if fibers are not broken, the traffic is still up. So both OSMs are raising the same alarm, meaning that they have been somehow forced to operate on 2 different sides of the ring. Let's confirm by checking their properties. Show OSM 4.2. Show OSM 8.2. At least 2 issues can be highlighted. First, as reported on the alarm list, the OSMs are working on 2 different legs. OSM 4.2 on the main. W stands for working, while OSM 8.2 on the spare. P stands for protection. Both have been forced by the operator. Second, at least one OSM is in blocked status since its switch count counter has reached the max switch count parameter. That is, in case of fiber failure, no switch is going to be taken. Also, note that two different counters have been configured against the two OSMs connected with each other. In case the two OSMs are working on two different sides of the ring, the PAE is also alarmed because of this loss of synchronization. Show PAE 4282. Yes, confirmed. The PAE is in loss of sync status. To unlock the OSMs, it is enough to reset the switch counters. Config OSM 42, reset switch count. Config OSM 82, reset switch count. Now, let's clear the switch status. In other words, let's release the force switch condition so that the two OSMs can switch in the case of a fiber cut. In other words, let's release the force switch condition so that the two OSMs can switch in the case of a future fiber cut. Config OSM 42, clear. Config OSM 82, clear. Since the selected legs of the two OSMs are still not matching, the PAE is still in loss of sync status. Show PAE 4282. If the PAE is not in revertive mode, the two OSMs will stay where they currently are, and therefore the alarms won't be cleaned up by themselves. Ultimately, it is necessary to switch the traffic of both OSMs over to the same side of the ring. In this case, we can move, for instance, the OSM 82 onto the worker direction. Config OSM 82 force worker. As we just forced a specific leg of the ring, we need to clear the force switch condition once more. Config OSM 82, clear. Then, we can check the PAE to see whether the blocking status is gone. Show PAE 4282. And yes, it's gone. To finalize the OPS configuration, let's make the PAE revertive, which is not a must, and let us configure the OSMs so that their parameters are consistent. The first task can be achieved with this command: config PAE 4282 revertive. Let's see whether it's now revertive. Show PAE 4282. It is now revertive as expected. To complete the second task, that is, the consistency of the parameters between OSMs, let's first check the OSM parameters to see their status. Show OSM 42. Show OSM 82. Three parameters don't match: bounce timer, evaluation timer, and hold-off timer. Let's fix OSM 42 to reflect the data reported in OSM 82, as three of these parameters look different. Config OSM 42 bounce timer 500. Config OSM 42 evaluation timer 550. Config OSM 42 hold-off timer 1100. We are now all done, and the two OSMs are finally consistent and free to switch in case of a fiber cut. Let's check the testing set. We can see that we had some traffic hits, and this is expected, as we switched the traffic from one leg to another, but if we clear the history, we can see that the traffic is still flowing. So to recap, to add a layer of optical protection to a VWM-based Fronthaul link, the OPS device can be used. One single OPS can host up to 4 optical switch modules to manage up to 4 protected rings with one single OPS device. The OSMs located at the terminations of the protected ring should be configured correctly. First, they must be configured so that both are using the same leg of the ring to avoid problems on the synchronization network. If this is not the case, an alarm is raised to warn the operator. Second, the two OSMs should be able to switch freely. In the case of too many optical switches, within a configurable amount of time, the OSMs enter a blocking status to preserve the traffic carried over the ring. Therefore, if the OSMs are blocked, they should be unlocked so that future fiber cuts can be managed. Third, the configurable parameters should be identical on the two OSMs belonging to the same protected ring. Here, we have counters and thresholds to manage the automatic protection mechanism. Once these 3 items have been checked and configured properly, the traffic is ready to be safely protected. Thanks for watching, and look for more videos in our Optical Networking Learning Essentials series. Whether your goal is to enhance your optical networking skills or demonstrate your expertise through one of our 4 industry-recognized certifications, the Optical Network Certification Program is here to get you, your career, and your organization on the right path. Our program features 9 instructor-led courses developed by our team of subject matter experts using industry best practices, use case-driven examples, and hands-on labs. Learn more and get started today by visiting our website. Thank you.